you. So what I do is I remember the range. The inverse trig function, the key is the range. So it looks like this. Ooh, right? And then, what does this do to the graph? It multiplies the x coordinates by 1/2. So, yeah. What does that do? It multiplies the y coordinates by 3. Ooh, finished. Okay, D. Y equal cotan inverse absolute value of x. So let's get the base graph down. Okay, the range for cotan inverse is from 0 to pi, so the graph looks like this, yeah? So if you know what the base graph looks like, how do you graph f of absolute value of x? What happens when the absolute values are only on the x? Erase everything to the left of the y-axis, keep and reflect the remaining portion about the y. Ta-da! 26. Decompose into partial fractions. Oh. Okay, so first step is make sure that this is a proper fraction. Yes. If it's not, then you got to divide. Okay, but it is. So now you got to think, okay, what fractions do I have to add together so that this will be the least common denominator? Something over x plus something over x squared plus something over x plus 2. Now remember, when you have a repeated linear factor like this, like for example, if you had x cubed, then you would need, if this were an x cubed, then you would have to have c over x cubed and then plus d over x plus 2. Right? Because if I add these three fractions together, that's the least common denominator. But it's not cubed, it's squared. Anyway, we don't want the problem taking longer than a minute, right? Right. Okay, first step. Get rid of the denominator. Multiply both sides by this. So you get 4 equal ax times x plus 2 plus b times x plus 2 plus c times x squared. I don't know why, but students have problems doing that sometimes. Now, either you're going to use the Heaviside method or equate the coefficients. In this case, I think Heaviside method is quite easy. So, Heaviside method means I'm going to plug in numbers for x. What's a good number to plug in for x? 0. So if I plug in 0 for x, 4 equals 0 plus 2b plus 0. Hey, we just figured out b is 2. What's another good number to plug in for x? How about negative 2? Right? Because it makes this and this factor 0. So you get 4 equals 0 plus 0. And if you plug in, you get 4c. C is 1. Now, we've run out of good numbers to plug in, but you still got to plug in one more number to figure out a. So pick a nice one. How about 3? How about 1? You don't have to pick 1. You can pick 7 if you want, but I think 1's a lot easier. 4 equals 3 times 1a. So that's 3a. Plug in 1 here. That's 3b, but we already know b is 2, so that's 6. Plus c, but we already know c is 1. So 3a is equal to negative 3, a equal negative 1. So your final answer is negative 1 over x plus 2 over x squared plus 1 over x plus 2. That's how you decompose into partial fractions. I'm skipping that problem, Mr. Park. Oh yeah? I'll show you. Alright, where are we? Number 27. F of x. So this is not really 40 problems because it's got part A, part B, part C. What's going on? A, find the domain. Now when you have a logarithmic function, to find the domain, you take the argument here. The argument has to be greater than 0. Solve that inequality and your money. Negative x is greater than negative 4. Divide by negative 1. X is less than 4. That's your domain. Now actually when you figure out domain, you're supposed to put it in set notation. But come on. I don't know. You got to read the directions because on the test it might say something like, the domain can be written in this form. Find the value of k. And of course, you put 4 on the answer line. So just make sure you read the directions. Nobody will get hurt. Okay, B, find f inverse. Now, this is like y. How do you find the inverse? You switch the x's and y's, and then you solve for y. So, first step, how do I get rid of the ln? You e both sides. So you get e to the x, and e to the natural log banana is banana. So y equals 4 minus e to the x. Finished! That's child's play. Okay, 28, evaluate. Okay, so we got to compute some limits now. What's the limit as x approaches negative infinity of e to the x? Probably the easiest thing is just to think of the base graph, which looks like this. So as x approaches negative infinity, that means what's happening as the graph is moving out to the left? Well, as the graph goes out to the left, the y-coordinates are getting closer and closer to 0 because the x-axis is the horizontal asymptote for this graph. Okay, B. What's the limit as x approaches 0 from the right of natural log x? Oh, so Mr. Park, we gotta know our base graphs. Duh. There's natural log x. So here's x equals 0. Coming from the right, the graph is exploding downward. So what's happening with the y-coordinates? They're going to negative infinity. Oh, my back! Bend over. C, limit, n approaches infinity, p, 1 plus r over n to the nt power. Hey, Mr. Park, isn't that the compounding interest formula? Yes. So what would happen if you take the limit as the number of times interest is compounded per year, it goes to infinity? Well, remember this, you gotta know this now. What's the limit as n approaches infinity of 1 plus box over n to the n? Remember? E to the box? Does that sound familiar? Okay, well, look at this. Let's low me. So I low me the thing. Look at the thing in the brackets. 1 plus box over n to the n. As n goes to infinity, the thing in the brackets gets closer and closer to e to the r. Put them all together, what have you got? Bibbidi bobbidi boo! Hey! That's the continuously compounded interest formula. Duh! Okay, next. D. What's the limit as x approaches infinity of 3x plus 1 over x minus 2? Well, actually D and E is the same graph, so why don't we just draw this graph? So, rational function, x-intercept, what makes the top 0? Negative 1/3. Y-intercept, plug in 0 for x, is negative half. Vertical asymptote, what makes the denominator 0? And if the degree of the top and the bottom are the same, you look at the coefficients, right? So y equals 3. So the graph got to go through these 2 points here. And since it's exploding down on this side, it's got to explode up on this side. So that's what the graph looks like. So let's answer the question. What is the limit as x approaches infinity? Well, as the graph is going out to the right, the y-coordinates are getting closer and closer to what number? 3! And then part E, what is the limit as x approaches 2 from the right of this same function? Okay, here's x equal 2. Coming from the right, look, the graph is exploding upward, so the limit is infinity. You just have to know where to look on the graph. 29. Man, you guys better appreciate this because I am getting fatigued. The fatigue is setting in. Okay, solve for x. This looks like a u substitution problem. U equal e to the x, so you get u cubed minus 6u squared plus 11u minus 6 equals 0. So we need to factor that, synthetic division. Okay, I'm just going to skip steps here because I'm really tired. If you do synthetic division here, you should get u minus 1, u minus 2, u minus 3. You know how I know that? Because I've given you that same problem like 5 times this year. So u is equal to either 1, 2, or 3, but remember your substitution. U is e to the x. And how do I get rid of e? You natural log both sides. Natural log of e to the x is just x. Natural log of 1 is 0. Natural log 2 is natural log 2, and natural log 3 is natural log 3. Mr. Park, what if I put natural log 1 instead of 0? Then you would get this problem wrong because you didn't simplify. And just a reminder, natural log 1 is 0, natural log e is 1. You know why? Because the base that's written is not written is e. E to the 0 is 1. E to the 1 is e. These are two numbers you just should know already. B. Natural log 1 plus x minus natural log 1 minus x equal 2. So what you want to do is combine these into just one logarithm. So using your property of logarithms, right? Like that. And how do I get rid of ln? You e both sides. E to the natural log banana is banana. And e to the 2 is just e squared. And how do you solve an equation like this? Cross multiply. Put all the x's on one side and put them on this side. put everything else on the other, factor out the x. And so therefore x equals e squared minus 1 over e squared plus 1. And since we have a logarithmic equation, you got to make sure that when you plug in the number, both arguments are positive. And are they? Yeah, so that's your answer. Otherwise, there would be no solution. I can't go on. Okay, now I see logarithms with different bases, so change of base. So I'm going to change, and since you're going to go to calculus next year, change everything to natural log. So natural log x over natural log 25, change here, natural log 5 over natural log 8. It's quite simple. The top thing goes on the top, the bottom thing goes on the bottom. And then of course, isn't 25 the same thing as 5 squared? Yeah, and then you can put the power in the front. Cough up the hairball. And then these cancel out. Okay, now there's several things you can do here. Why don't we just cross multiply right here? So natural log x is equal to 2 natural log 8. Put the 2 up as the power. Natural log x equal natural log 64. E both sides, x equals 64. And that's one way to do it. Whatever, just get the job done. 30. The half-life of a radioactive substance, so y equal y naught 1/2 is 7 minutes, t over 7. You guys remember how to do that? Well, then you better review this. How many minutes will it take for 80% of a given amount to decay? Well, if this is your original amount and 80% of it decays, how much is left? 20%. So what do I plug in for y? 0.2 y naught, or if you're working with fractions, 1/5 y naught. And then what do you know? The y naughts cancel out. And then how do I solve for t when it's in the variable like that? You use logarithms. Natural log both sides. Natural log 1/5 is equal to natural log of 1/2 to the t over 7, but you can put the power in the front. That's why we have logarithms. And then you just solve for t, which is 7 natural log 1/5 all over natural log 1/2. And then, depending on how you need to simplify your answer, that can be, now remember, this is like 5 to the negative 1. That's like 2 to the negative 1. You put both negative 1s in the front, they cancel out, so you get 7 ln 5 all over ln 2. Woo! Alright, 31. They're kind of making progress. X equal arctan 4/3. Y equal arctan 12/5. So we're in the trig part of the test here. You guys should be experts in this. Compute that. Well, you got to know identities. So, cosine x, cosine y, minus sine x, sine y. Yeah, but Mr. Park, if I know this, how do I figure out this? You draw the triangle. Remember, inverse trig functions are angle measurements. So 4, 3, 5. And then, what about for y? 12, 5, 13, like that. Draw the triangles. So, looking at the picture, cosine x is adjacent over hypotenuse, adjacent over hypotenuse, minus opposite over hypotenuse, times opposite over hypotenuse, and then you just simplify it. I think you can handle that. D. Oh, so Mr. Park, I gotta know all my trig identities. Duh. So 2 sine x, cosine x, and then just look at your triangle. Sine is opposite over hypotenuse, adjacent. Make sure you look at the right triangle. This is the x one, yeah? And then C, tangent x over 2. Now, tan x over 2 got 3 identities, but which is the one I told you to remember? 1 minus cosine over sine. That's the bestest one to use. So, looking at your picture, cosine x is 3/5. Sine is opposite over hypotenuse. Multiply top and bottom by 5. 5 minus 3 over 4, 2/4, which is 1/2. Oh. D! I'm running out of chalk. Replace. Gosh, you guys don't even let me drink water. I'll show you. D. Where are we? Oh, cosine 2y. Now, cosine 2y, there's 3 identities. Pick your favorite one. Like I keep telling you, my favorite is cosine squared minus sine squared. And make sure you put y there so you look at the right triangle. So looking at this triangle, cosine is adjacent over hypotenuse, and then you gotta square it, minus opposite over hypotenuse squared. Okay, I will leave the simplifying to you. 32, recognition of identities. Cosine squared pi over 8 minus sine squared pi over 8. Hey, you somebody! That's the double angle identity, right? Cosine squared minus sine squared. That's the identity for cosine of 2 theta, which of course simplifies to pi over 4. Hey, you somebody! 1 over root 2. Cotangent squared pi over 12 minus cosecant squared. Now you can actually compute those numbers there, but hey, you almost somebody. If I factor out the negative sign, you get cosecant squared minus cotangent squared. And then, hey, you somebody, yeah? That's right, that's 1. What? Well, if you remember the identity, cotangent squared theta plus 1 equals cosecant squared theta. Remember Pythagorean identity? So what would be cosecant minus cotangent squared? Be 1. So negative 1. You just have to low me a little bit. Okay. And then we got 30. Oh, we got a part C here. Sine inverse negative root 3 over 2 plus cosine inverse negative root 3 over 2. Okay, what does sine inverse negative root 3 over 2 mean? It means sine of what angle is negative root 3 over 2, but your answer has to be in the range, which is from negative pi over 2 to pi over 2. So that's why this is negative pi over 3. Cosine, and what does this mean? This means cosine of what angle is negative root 3 over 2, but the answer has to be in the range, which for cosine inverse is 0 to pi. So this one is 5 pi over 6, and I will leave that addition to you. So I gotta know the range then. Negative 24 seconds. Okay, sine of 1/2 theta. Remember, inverse trig functions are angle measurements. So think of this as theta. You can draw a picture for it. Right? Tan is opposite over adjacent, so that's 25. But the range for tan inverse is from negative pi over 2 to pi over 2. And so since it's negative, this is in the 4th quadrant. It's a 4th quadrant thing. All right. So what's the identity for sine of theta over 2? Plus or minus the square root of 1 minus cosine theta all over 2. So the first part is you got to figure out whether it's plus or minus. Now, this angle here is in the 4th quadrant, but it's a negative angle. It's like this. So what would happen if you half it? It's like negative something. If you half it, it's still going to be in the 4th quadrant. Sine of a 4th quadrant angle? Negative. So you got to pick the negative one. And then now you look at the picture for cosine theta. What's cosine theta? Adjacent over hypotenuse. But is it 7/25 or negative 7/25? Well, in the 4th quadrant, what is cosine? Positive. So there you go. And if you remember doing this number comes out quite nice, yeah? I gave you that a lot. I will leave the simplifying to you. Okay, where are we? Oh, right there, E. Simplify this. Well, remember, e to the natural log banana is banana, right? Since they're inverses of each other. Yeah, but Mr. Park, there's a 2 there. Well, since you have a logarithm, you can put the 2 up as the power. And then now, you have e to the natural log banana is simply banana, so the answer is 9. That comes up a lot in calculus. You got to be able to simplify that quickly. Okay, 33. Simplify. Now, there's several ways of simplifying it. Like some of you might be going, hey, you somebody. But if not, let's just do the mundane way. Cosine 2x, there's 3 identities. Which one do I want to use? Do I want to use 2 cosine squared x minus 1 or 1 minus 2 cosine squared x? You want to use 1 minus 2 sine squared x. How come? Because when you distribute the minus signs, the ones cancel out, it becomes simpler. And then which one do you think I'm going to use here? 2 cosine squared x minus 1, because the ones cancel out. So if you simplify the top, you're just going to get 2 sine squared x, and if you simplify the bottom, you get 2 cosine squared x, the 2's cancel out. Final answer, survey says, tangent squared x. Or some of you going, hey, use somebody from the half angle identity. And if you don't know what I'm talking about, then just do it that way. Okay, where are we? 34. Find all the asymptotes of this. Okay, let's draw a base graph, cosecant. Cosecant is the reciprocal of sine, right? So sine goes like this, remember? Sine. Okay, here's 2 pi. Okay, and then remember, cosecant. Hump up. That's 1. That's negative 1. Hump down. Now, what does this do to the graph? It multiplies the y's by 2. I don't think that's going to affect vertical asymptotes there. This multiplies the x coordinates by 4 over pi. So if this gets multiplied by 4 over pi, it becomes 8. This becomes 4. That becomes 0. And then what does this do to the graph? It shifts everything 3 to the right. So this asymptote goes 3 to the right. So here are your asymptotes. Dot, dot, dot. Going to have 3. And then if this goes 3 to the right, 7. If this goes 3 to the right, 11. And it keeps on going forever. Now, if you look at the answer I had on the bottom, it's like x is equal to 4k minus 1, where k is an element of the integers, right? But if you don't understand that, then just do this. Dot, 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 3, 7, 11, dot, dot, dot. So that means keep following the pattern in both these directions there. All right, 35, solving trig equations. So here we go. And it's only between 0 and 2 pi now, so that makes it a lot simpler. Okay, double angle identity. Which one am I going to use? Well, you're going to use this one. You know why? Because that side is sine. You're going to make it all one variable. It's quadratic, so you make one side 0. Factor. And then 1 plus or minus. So sine x equals either half or negative 1, and these are numbers we're supposed to know. Pi over 6, 5 pi over 6, and 3 pi over 2. Hopefully we're good at that by now. B, tan 3x equals 1. Now that's a number we're supposed to know for tangent, so just think of it as tangent of what angle is 1. Boom! Pi over 4, 5 pi over 4. However, since the variable is 3x, that means we have to go 3 times around. So add 2 pi to each of those. What did I just say? See, I'm getting tired. I can't even think already. Add another 2 pi, which is 8 pi over 4. Woo! Okay, and then finally divide everything by 3. Yeah. But that's why you have to go 3 times around, because you're going to divide everything by 3. And then inequality. Oh, grasshopper. Okay, so double angle identity. Now, what's the procedure for solving inequalities? You make one side 0. Do not cancel the cosine x from both sides. That would be a fatal error. You factor out the cosine and you get 2 sine x minus 1. Okay, so you make one side 0. You factor it. Now we make a number line. Okay, what makes this thing 0? Pi over 2, 3 pi over 2. What makes this factor 0? Pi over 6 and 5 pi over 6, right? And then you test the number line. Think of a number over here like 0. If I plug in 0, cosine of 0 is 1, which is positive. Sine of 0 is 0. 0 minus 1 is negative. Positive times negative, negative. And then just alternate signs. No moose breath. When you have trig functions or any transcendental function for that matter, there is no pattern, so you have to test each one separately. However, there is a little shortcut you could use. If you plug in 0 and you get negative, then when you plug in 2 pi, you should also get negative, right? Because 0 and 2 pi should yield the same results. But then you're going to have to plug in numbers over here. Like I'll do one more for you. Plug in like pi over 3. Cosine of pi over 3 is 1/2, which is positive. Sine of pi over 3 is root 3 over 2. Times 2 is root 3 minus 1 is positive. So positive times positive is positive. That's what you got to do. And you just keep on doing it. And then, here, I'll just fill it in. See, Mr. Park, it alternates. Yeah, in this particular problem, but I'm telling you, and you guys seen it for yourselves, it doesn't always do that. That's why you have to test every region. Okay, we're nearing the end. I see the light. Walk to the light. Okay, let's draw a picture here. Triangle A, B, C. B is 60 degrees, A is 5, and C is 8. Find B. Well, if you don't have a right triangle, and you have SAS, then you need to use the law of cosines. So, B squared is equal to 8 squared plus 5 squared minus 285. Cosine of 60 degrees, but we know cosine of 60 degrees is 1/2, and I think you can do the computations from there, right? I don't trust you. So 64 plus 25. This looks like a quiz problem we had. Then 40, so that's 49. B is 7. Hey, Mr. Park, I noticed lots of times when you get law of cosines, the answer comes out 7, or a multiple of 7. Duh. Okay, find the area of this triangle. What's the fastest way to find the area of a triangle if you know two sides and the included angle? 1/2 AB sine C. That's the fastest way, and of course that's a number we know. Root 3 over 2. I think you can take it from there. Okay, 37, we're almost there. Write the equivalent rectangular equation. R equals 2 over sine theta. Now we just did polar, so this should be like fresh in your head right here. Cross multiply. R sine theta equal 2. Hey, you somebody. That's y. Y equal 2, which is just a horizontal line 2 units above the origin. And do you have to graph? No, you just have to write it. So the answer is just y equal 2. B, theta equal 3 pi over 4. Tangent both sides. Now why would you do that? Because, hey, you somebody. That's y over x. And then that's a number I know. So y equal negative x. That's why you do it. 38. Oh, now we got a graph. Okay, let's erase it. This could be the last of it. We are down the home stretch. 38. Oh, great. Oh, we gotta find points of intersection. Okay, that's a circle. And what is this? That's a cardioid. Okay, here we go. So how do I find where these two things intersect? You said, well, substitution. So 2 sine theta. So since this is equal to r, you can substitute it there. Okay, maybe 4 sine theta equal 2. Sine theta equal 1/2. So theta equal pi over 6 or 5 pi over 6. But you gotta remember, we're giving points of intersection. We just found the theta coordinates. How do you find the r coordinates? You plug it back into one of the original. I think this one is easier. Sine of pi over 6 is 1/2 times 2. 1. 1/2 times 2, 1. Okay, those are your algebraic points of intersection, but there could be graphical points of intersection. That's why we need to draw the graphs. Okay, that's a circle. Remember the fast way to graph a circle? Plot 2 points, one at 0 and one at pi over 2. 0, plug in 0, you get 0. Plug in pi over 2, and you get 2. Woo! So, and remember, when you graph it from 0 to 2 pi, the thing goes around twice now. What about that one? Plot the 4 quadrantal angles. 0, you get 2. Pi over 2, you get 0. Pi, 2. 3 pi over 2, 4. You have to, not negative 4, it's 4. You have to go 4 in the direction of 3 pi over 2. And there is your cardioid blowing to the north. Okay, so let's check out the points of intersection. Measure off an angle of pi over 6 and go 1 unit from the origin. Check! Measure off an angle of 5 pi over 6, go 1 unit from the origin. Check! So, but I can clearly see they intersect there, so we have to say the pole is a graphical point of intersection. 2 more problems and I'm done. Doo-dah, doo-dah. Number 939. Okay, simplify this. Now this one would be a little too complicated for the final exam, so probably if you can do this one, you can do 2 problems on there. Okay, so what you want to do is, there's no way you want to raise this to the 10th power. We want to use de Moivre's theorem, so my body. We need to change this to polar form. Both of these we're going to change to polar form. Okay, now what's the fastest way to change from rectangular to polar? Draw the picture. If I go 1 to the left and 1 up, like this, 1 to the left and 1 up, how far from origin am I? 2. And what's this angle going like that? 3 pi over 4? Okay, now what about this one? If I go radical 3 to the right and 1 down, how far from origin am I? 2. And what's this angle now? You got a choice. Do you really want to go all the way around, or you want to just go negative pi over 6? You want to go 11 pi over 6 or negative pi over... It doesn't matter. Just pick one and go. I'm going to go with negative pi over 6. You know why? If you have foresight, you can see why. It really doesn't matter. Just pick one and go with it. Okay, now, how do you raise a complex number to a power? You use de Moivre's theorem. So you raise r to the power. So what is root 2 to the 10th power? And then you multiply the angle times the power. So that's 30 pi over 4, 15 pi over 2. Okay, use de Moivre's theorem on the bottom. 2 to the 6th power, 64. Kiss. And then you multiply the angle and the power, negative pi. And then how do you divide complex numbers? Well, you divide the r's. And then what do I do with the angles? You subtract. What is this minus that? 17 pi over 2. No, Mr. Park, 17 pi over 2, I don't know. Well, isn't that the same thing as 8.5 pi if you change it to a mixed number? Now remember, to reduce the angle down, just subtract multiples of 2 pi. What is a good multiple of 2 pi to subtract from that? 8 pi. So if you subtract 8 pi, you simply get pi over 2. And then, changing it back, remember, KISS is an abbreviation for cosine theta plus I sine theta. And then you just got to know your trig values. Let's do it here. That's 0 plus 1i. Distribute the 1/2. Final answer, survey says 1/2 I. Last problem. Z cubed is equal to negative 8i. Now the first thing you want to do is change this into polar form. So you might want to put the 0 there. Now, again, change it to polar form. If I plot the point 0, negative 8, you can be down here. How far from origin am I? 8. What's this angle going around there? 3 pi over 2. Okay. Now we're going to use the complex roots theorem. Now remember, there's going to be 3 answers, right? Fundamental theorem of algebra. Polynomial equation of degree 3 will have 3 solutions. So, just plug and chug. Z equals the cube root, this is n, this is r, this is theta. Just plug it in. Cube root of 8, kiss, 3 pi over 2 plus 2k pi all over n, where k is equal to 0, 1, and 2. We just did this. So to get your 3 answers, you simply plug in 0, 1, and 2 for k and you're done. So the first answer, 2, kiss. If I plug in 0 for k, you get 3 pi over 2 divided by 3, which is simply pi over 2. Now remember, I told you a shortcut. Once you figure out the first one, they're all going to be equally spaced apart. So if the first one's at 90 degrees, and they're going to be all 120 degrees apart, the next one's going to occur at 210. So that's 2 kiss 7 pi over 6. And then the next one's going to occur 120 degrees later, which is 11 pi over 6. And then, of course, you have to change them back. Now, you got to read the directions on the test, because if I tell you leave the answer in polar form, then you just leave it like this. But if it says standard form, you got to change it back. So remember how to change it back? KISS stands for cosine theta plus I sine theta. And then that's 0 plus 1i, distribute the 2, 2i. So that's the first one. And you do the same thing with the other 2. So you're going to end up with 3 answers. Woo! All right. Time to put it on YouTube. And then you guys can watch it. How long is this critter? 1 hour, 24 minutes. Goodbye.